annual force of interest is 2 over 10 minus t. Calculate equivalent annual nominal discount rate compounded every 2 years for the period 2 to 2.4. So force of interest is not constant, therefore we will have the amount equals principal times e power integral of the force of interest. And now it doesn't matter in this case, since we are to convert a force of interest into an equivalent discount rate. So it doesn't matter what the principal is. So let's suppose that the principal is 1, that is the simplest. And so from time 2 to 2.4, that's the period for which we want to calculate the annual nominal discount rate. Because since the force of interest is variable in this case, so the discount rate or the interest rate will vary from period to period. Therefore, it's not just enough to say that calculate the annual nominal discount rate. They have to mention over which period, because it will change depending on the period. If the force of interest was constant, then the corresponding discount rate or interest rate, the compound one, is also constant, but not in this case because force of interest is variable. So we want the discount rate, the nominal discount rate from 2 to 2.4, and therefore we first calculate what will be the amount with a principal of 1. If we go from 2 to 2.4 under the force of interest, so we have e power integral 2 to 2.4 of 2 over 10 minus t. The integral of 1 over 10 minus t will be negative ln 10 minus t, and then we have a 2 also, so negative 2 ln 10 minus t, and limits 2 to 2.4. So we substitute the limits, and we end up with 1.108. So a principal of 1 will grow to 1.108 from time 2 to 2.4. Now we have to calculate the nominal discount rate compounded every 2 years. And so by our 9.2 equation, which if you forgot about, you can review lesson 9 again. So the formula is A of t equals principal times 1 minus d power m by m power mt. And we are taking the principal to be 1. And when the compounding happens every 2 years, the m is a half. Remember, m is how many compoundings you have every year. So if there is one compounding in 2 years, then it means that in one year there is half compounding. So that's why m is a half in this case. And once again, the period of interest is between 2 and 2.4. So that is a period of 0.4 years if we subtract 2.4 and 2. And here in this formula, t is the duration. So the duration from 2 to 2.4 is 0.4. That's why t would be 0.4 in this case. So A2 is the amount under the discount rate. So that would be 1 minus d to the half over half power negative half times 0.4. So that this 2 comes in the first line. So this one simplifies to 1 minus 2d power 2d superscript half. And the half times 0.4 is 0.2. Now for the two kinds of interest rates, the force of interest and the nominal discount will be equivalent. The corresponding amounts over the interested periods should be equal. So under the force of interest, we found the amount to be 1.108, and under the nominal discount rate. It's given by this equation 2. So we set the two equal. 1.108 equals 1 minus 2d superscript half power negative 2. And we raise both sides to the power negative 1 over 0.2. So we get 0.5988 equals 1 minus 2d superscript half. And the goal was to find d superscript half. So after we do the algebra here, we get it to be 0.2006 or 20.06%. That is choice A.